Hello, welcome back. I'm Andreas Chatt, your tech-curious web designer. In this video, we will take a quick peek into the world of automated testing. While manually testing a website is great, testing all the features every time we deploy code is just not feasible. This is why it's crucial to write automated tests to check if everything still works when new code is injected into the existing codebase. For this, I will show you how we can build some basic functions to test the main features of our application. And in a second step, we will build a workflow with Github Actions, which runs those tests automatically when we deploy new code. Okay, with that said, let's get started. So writing tests can be quite tricky and can take much more time than testing features manually. However, the bigger the application gets, the more important automation becomes. That's why many programmers practice test-driven development, TDD in short, which involves writing the test code before the actual code. Alright, so let's write some tests now. So each of our apps in Django comes with a test file. So for example, if we go to our post folder, we can see the test.py file here. So in here, we write our tests. So first, let's start with a very simple test to check if the sign up page exists. So we create here a class. We can name it whatever we want. I call it sign up test. And it's inheriting from the test case class. This class is, for example, responsible to set up a test database and rolls it back when the tests are finished. It provides a test client, which we will use to simulate a browser to make HTTP requests, and it contains many assertions. These are functions which allow us to make statements about an expected behavior of our code. We will see all this in action soon. And in this sign-up test class, we write our test functions. And my very first function is to check if the sign-up page actually exists. All the test functions we need to prefix with a test underscore. This is how Django understands that this is a test function to run. The self parameter is used when defining a method within a class. With it, we have access to the class itself and all its methods. Alright, and now let's define a response. So response equals self.client. So self.client is behaving like our browser, and we can make requests with the get or the post method. Here now I'm trying to get the sign up page, so .get. And here we add the URL of the sign up page. And instead of hard coding it, I use the reverse function. Reverse, and in parentheses, the name of the URL pattern. And the name of the sign up page URL is account underscore sign up. This is coming from our all-auth package. Alright, let's import this reverse function. From Django.urls import reverse. Okay, now that we have the page response, let's test if the page exists. For this, we use now the assert function. Self.assert equal. As we can see here from the dropdown, we can assert many things. The most common one is assert equal to test if two values are the same, and if they are not, the test fails. So in this case, I assert equal the response dot status code to be 200. So 200 as a status code means, okay, I have found the page. And here we check if the value of the status code is indeed 200. So let's test this now. We save this file, and in our terminal, we run now the test with Python manage.py test, like that. My test here takes a lot of time to run, and this is because I'm still connected to the remote Postgres database. I will switch back to the local database in a second. Okay, we can see here now it ran one test. So this dot here stands for one test, and everything seems okay. I quickly switch back to the local database now, change this to false, and now our test will run very fast. Alright, just to double check that this test actually worked, we break the code now by making, for example, a slight change in the URL name. So I will just add here an S and save this file and run the test again. And this time it failed, as expected. The reverse of this URL patterns was not found, because this URL obviously doesn't exist. Okay, let's change it back and run it again. And we get the OK. Nice. Let's check now if the sign-up page uses the correct template. For this we use the assert template used method, and we check here if the response uses the signup.html template. Okay, let's save this file, and let's run the test again. So everything is still okay. Great. So this is my first basic test. Now I add my second test. In the second test, I would like to check if I can sign up with a new user. So I'm calling this function test underscore signup user. And first I define some user data. So I'm creating here a user data variable. And then in a dictionary here, I just add data for email, username, and the password. So this is all fake data just for testing. Okay, and now we build our response. So response equals, again, self to client. But this time we basically fill out the form on the sign up page. So the request method in this case is post. So we say dot post. And here at the URL I want to send this form data to. So reverse account underscore sign up. Then I'm supplying my user data. And I also supply the format of this form. So format equals text/HTML. All right. So to check if a post request worked, we expect a redirect to happen. Because if the form is valid and the user is signed up correctly, we will get a redirect to the home page. So let's check that. We can grab the line from here. There we go. So if I test this one now, I expect an error because the status code of a redirect is 302. Let's test this. So again, pyth manage.py test. And as expected, it raised an error here because the status code of 302 is not 200. So let's change this to 302 for a redirect. Save this file and run the test again. And now it works. We run 2 tests and both tests passed. And now I would like to check if the profile page was created. So whenever we sign up with a new user, our application will create a new profile page using signals. Let's check this. So here I'm taking the user profile URL and pass through the username as an argument to get the correct profile page. And the value of the username we're getting from our user data. And now we check if this user profile page exists. Save this file and run the test. And yes, it found the profile page of that username. Now I want to test the profile edit page. To do this, we need a logged in user. To make this user also available for other test functions, I create a setup class that can be inherited by other classes. So I'm calling this class base setup, which inherits again from the test case class. Let's create our setup function. So def setup and self as a parameter. So I don't prefix this function with test underscore because I don't want Django to test it. This is just to set up a new user. So here we grab the user data from before and also create an account. Like that. So with this function we have now a signed up user, which we can use to test other features in our application. So let's test now if changing the email address on the profile page works. Okay, for this I create a new class now. I call this class profile edit test. And this class inherits now from the base setup class, which we just set up with a signed up user. My very first test here is if I can access the page itself. So test underscore profile edit and in parentheses self. And then response equals self.client.get reverse of profile-edit. This is the URL to our profile edit page. And then we check if this page exists. So self.assert equal if the status code of this response is 200. Okay, save this file and let's run a test. And yes, it ran 3 tests now and they are all okay. Alright. Now this edit profile page should only be accessible for logged in users. Let's check this also quickly if that works. For this we easily can just log out like this. So self.client.logout. So this is logging out my user. So let's save this file, run the test, and we expect an error now. And indeed, that tells me that this profile edit page is only accessible when I'm actually logged in. Great. So let's get rid of this line and let's carry on. Now I'm testing to change my email address. So I'm creating here a form variable, form underscore data, and I say my email should be test2@email.com. So I have to indent here the form so it sits within this function. And now I'm adding the response. So I'm sending a post request to the profile edit function and I attach the data. Alright. And we check if we get a redirect. Okay, save this file and run the test. And yes, this worked as well. Now let's check if this email address was actually updated on the profile object in the database and also in the user object. Both profile and user should have now this test2 email address. So for this we first create the user. So self.user equals. So here we're accessing now the user table. User.objects.get. And here I'm accessing the user by username. So username equals, and our username is test user. Okay, like that. So let's import our user class. And now we can test if the user object has this test2 email address. So let's save this file and run the test. And yes, we get an OK. Let's test also the profile object now. So profile equals profile.objects.get, and here I'm looking for the user equals self.user. Let's import the profile class. So from a_users.models import profile. And then we assert that profile email is equal to test2. Alright, save this file and test. And yes, everything passed the test. Now the last test I would like to do is to test if you can create a post. So for this I'm adding here a new class. And I call it post create test. Is again inheriting from the base setup class. And now I'm writing my test. Post create. Alright. First again I check if the post create page exists. Like that. Save the file and run the test. As we can see here, this is our fourth test, and it found the post create page. Great. Now let's provide some form data to create this post. So form_data. So what we have to provide is our URL. So this is just a dummy URL. And the other property we have to provide is the body. So body and some dummy text, lorem ipsum. Alright, this is our fake data. Now let's add all the data we need to create a post, and for this I'm not using the web crawler itself, but just some dummy data. So I'm creating here a variable called post_data. And here I'm adding again the URL from the form_data. And then in square brackets, I access the value of the URL, like that. Then next we have also the body, form_data, and body. Then I'm also adding here the title, test, then an image link, this link just generates me a random image in the size of 500 by 500 pixels. Then we have the artist, I call him Steve, and we have also the author. And the author is our user, so self.user. Okay, with this data now we create our post. So post equals post.objects.create, then do asterisk post_data. So the double asterisk here transforms dictionary data into keyword arguments, which can then be passed to the function as parameters. Okay, let's import also the post class. So from .models import post. And then I'm checking here if this post object exists in a database. Here I'm saying self.assert true. And I'm trying to find a post with the title test. Alright, save this file and let's run the test. So here I'm getting now an error for the self.user value on the author key. So it says that the class doesn't have the self.user attribute declared. No problem at all, let's declare it now. So let's do this here. Self.user equals user.objects.get and the username equals to test user. Just as a side note here, I should have declared this user in the base setup class. Then I would have had access to it everywhere. Let's run the test again. And now everything is okay. Alright. Now let's check if this post also exists on the home page. Let's create a variable, homepage equals self.client.get, then reverse of the home URL, like that. And now we check if the homepage contains test, which we used as the title of our post. For this we're using here the method assert contains. Alright, save this file and run the test. And indeed, it found this post on the homepage. Awesome. So at last I would like to test if by deleting this post it doesn't show up on the homepage anymore. So for this we first delete the post. We can easily do that by post.delete. And here I'm requesting my homepage again. This basically mimicking a refresh. And again I'm asserting that the homepage contains the string test. But this time this should give me an error. Save this file. Let's test it. And indeed it failed, because it couldn't find test in the response. To make this test pass, we could change the method to assert not contains. Like that. Okay, save this file and run the test again. Perfect. Okay, we've written now 4 tests, which check if the user can sign up, edit the profile page and create a post. And I hope this has given you a basic understanding how writing tests work. Now, obviously we don't want to run manually this test command every time we deploy new code. That's why let's have a look how we can create an automatic workflow. We can use Github Actions for this. So Github Actions creates a testing environment on GitHub, builds up the application, runs the test, and then destroys the testing environment when the tests have finished. Our job is now to tell GitHub Actions all the steps it needs to do to build our application and what commands to run. For this we create a special file, a YAML file, which is often used for configuration files in applications, workflow definitions and running commands. So to create this file we go to our source here, add a new file. Then first we create a GitHub folder with .github, then /workflows, / and then the name of our file. So I call my file awesome testing. awesome_testing.yaml, so YML. So to write this file we have to follow now a structure so GitHub is able to execute it properly. First, let's give this workflow a name. So name, colon, and I'm calling it awesome testing. Alright. So next I define when this workflow should be triggered. And I want it to be triggered on every pull request to the staging branch. So on pull request, colon, make sure to have the correct indentation. So here write branches. You can add here more branches, but I only want to test the code when merging into the staging branch. So I add here staging. Like that. Alright, and now we add the jobs it should do. So the first job I give to GitHub Actions is to build my testing environment. So I call this job build. So here I'm defining first the operating system it should run on. Most servers run on Ubuntu, so let's take that one. Runs -on : Ubuntu -latest. So we are installing here the latest Ubuntu operating system. Now next, for our environment to run properly, we also need environment variables. So our Django application runs with two necessary environment variables, and this is the secret key and the encryption key. And we will also run it in our development environment. So we add them with env colon environment colon development. All right. Then we have the secret key. Now the secret key can be anything, so we can just add here some content, so secret underscore key. Then we have also encryption key. However, this encryption key requires a certain format. For this, let's generate a new key just for the testing. So in our terminal, I just open the Python shell quickly. So Python and enter. Now we're in the Python shell. So first I am importing the fernet class from cryptography.fernet. Then I'm creating this key. So fernet.generate underscore key. Now that we have the key, we can print the key. So print key. Okay, here we have a string in binary format. We only need the string itself, so I copy all those characters here and paste it to my encryption key variable, like that. Okay, we can exit now from the shell with exit and parentheses. All right, now we set up our environment variables. Now we are ready to spin up our Django application. Here we add now the steps one by one. So steps. So the first step involves copying all the files from our repository over to this new testing container. So here for this we write users colon actions slash checkout at version 4. So the checkout action is cloning our repository now into a runner environment where the workflow is executed. And I'm using here the latest version. You can find the latest version on the Github Actions documentation. So next we install Python in this container. Actions slash setup dash Python at version 5. With this action we install Python. Again, the v5 relates to the version of the setup Python action, not the Python version. Let's declare that one now. With colon Python dash version. And the Python version I am using here is 3.11.3. All right. Next we run a few commands. So the first command is to upgrade pip. So run Python -m, so the module pip install -- upgrade pip. All right, then we have the next step, installing all our dependencies. So pip install -r and requirements.txt. All right. And as last step, we finally run the test. So run python manage.py test. All right. So this is my YAML file. This should trigger now the test on GitHub. Well, let's check it out if that works. Okay, we save this file and let's push it to GitHub. GitHub Desktop shows me here the new and updated files. Let's give the commit a title, auto testing. Okay, I commit to my feature branch on GitHub and push origin. Okay, now we create a pull request to the staging branch. We switch to the staging branch here. and create pull request. Before we click merge, Github Actions should run the test. And as we can see here now, it started running the test automatically. So it's building the testing environment at the moment and then run the test. This will take a couple of seconds.
A few inches later.
Alright, this took 44 seconds and unfortunately our test failed. Let's have a look why. So if you click here details, these are the logs of the build and we can see here where the error is. And this seems to be connected to the cloud name environment variable, which we actually should not need because we're using the development environment. So let's check out what the problem is. Let's go to our settings.py file. So in the core folder, settings.py, let's find the cloud name variable. So here we have the cloud name. And as we can see here, the cloudinary storage declaration is outside of our environment if-else statement. So I just cut the code from here and move it in our production environment. Like that. Because we only need those information when we are actually in our production environment. Okay, that should fix the problem now. Let's save this file. And let's push it again to GitHub. We can also see here the test failed. But let's see if this change worked. So we commit again to our branch with the title update settings.py, push origin. We don't have to create a new pull request here because we are still in process of resolving the current one. So let's go straight to GitHub. We click here on pull requests, auto testing. And it seems like our tests are already done and we're successful. Update settings.py file has a pass now, while the previous testing has failed. Alright, then merge pull request and confirm merge. And there we have it, we merged now successfully into our staging branch with an automated test. If you go to actions here, we can see our two workflows we have run so far. Let's just do another test. So in my project, I'm deleting the staging.txt file. This is just a dummy file. So I delete it from my project. Okay. And push the codebase again to GitHub to trigger the test. We deleted staging.txt, commit to my feature branch, and push origin. We create a pull request from my feature branch to the staging branch, create pull request. We have another test starting now. We can look at the details. Here can we see the whole process. It's installing all the packages now. Then running the tests. And our test passed. If we go to action here, the latest test got an OK. And we're good to merge into the staging branch. I select here the latest pull request. Okay, merge pull request and confirm merge. Alright, that's it. We successfully integrated now an automated test workflow into our CI pipeline. Alright, this is all for this video. Thank you for watching. So in the next video, we will build a maintenance landing page in case we need to make significant changes to the site and have to take it down temporarily. And we will also create a password protected landing page in case we want to keep it locked from the public. I hope to see you there. Until then, happy coding! and Merry Christmas!